Hi everyone! In this video, we'll go through some possible scenarios you might see when trying to factor quadratic trinomials. Now just a reminder, quadratic trinomials are going to look like the form ax squared plus bx plus c, where a, b, and c are all integers. Now, the special one that we'll see, we call a the leading coefficient, because it's the coefficient that's on the term with the highest exponent. In this case, it's x squared. So the leading coefficient is going to be whatever number is in that a spot. All right, so keep that in mind as we move along. Let's get right into the first scenario. You might see some trinomials that don't have a leading coefficient. Right? We don't see a number other than the one that's automatically there. We don't see a number in front of this x squared. We can go right ahead and factor. To do that, we need to find two numbers that multiply to be 75, and those same two numbers need to add up to negative 28. And then the way that we showed you how to organize this in class might have been the area method, or might have been using the x just to organize our thoughts. Now we need two numbers that multiply to 75. Those same two numbers need to add up to negative 28. Okay? Now, it needs to multiply to be a positive number, but it needs to add up to be a negative number. Well, the two situations to multiply to be a positive are positive times positive or negative times negative. It needs to add up to be negative 28, so let's go ahead. Both of the numbers that we find need to be negative. In this case, negative 25 times negative 3 equals positive 75. But then adding them together, negative 25 minus 3 is negative 28. So we found our numbers that work. We write our final answer as x minus 25 times x minus 3. Right? So we broke our trinomial down into the two factors that if you multiply it together, you would get x squared minus 28x plus 75. Go ahead and try numbers 1 and 2 on your own. Pause the video and then come back to check. Okay, so the final answers to these are the factored form are highlighted in blue. Let's go on to the next scenario. You might see a polynomial that now has a leading coefficient that's not the GCF. Right? Our leading coefficient is 3, but there's no factor that 3x squared, negative 14x, and 15 have in common, so we can't factor out our GCF. So we're going to go ahead and use our grouping method to go ahead and factor this trinomial. Let's use our x to organize and go ahead with our method. Now because this has a leading coefficient, we can't go ahead and put a 15 up top and a negative 14 below for multiply and add. Because of this leading coefficient, needs to multiply to be 45, 3 times 15, and add up to negative 14. Now again, both of our numbers need to be negative. Negative 9 times negative 5 is 45. Negative 9 minus 5 is negative 14. So we found our numbers. These numbers tell us how to split up this middle term in our trinomial. We're just going to rewrite it. 3x squared. But instead of writing negative 14x, since we just found the negative 9 and the negative 5, we're going to write it out like that. That way we can use our grouping method. Right? Essentially, this polynomial and this polynomial are the same exact thing. Right? We just split up that middle term. Now we can go ahead and group. Find the GCF between 3x squared and negative 9x. GCF is 3x. We're grouping our terms. When we factor out a 3x from 3x squared, we're left with x. When we factor 3x out of negative 9x, we're left with minus 3. Then we just do the same thing for the second two terms. GCF between negative 5x and 15 is negative 5. And when we factor that out from here, we're left with x minus 3. Right? Then we look at this step. Both of these terms have the x minus 3 in common. So let's take the x minus 3 and write that out front. And when we factor that out, we're left with 3x minus 5. And that gives us our factored form. All right, go ahead and try number 3 and 4 on your own, then come back to check. Okay, again, we see that in these trinomials, there was no GCF between all three terms. So we used our grouping method. We split up that middle term, factored out our GCF, and got our final answers. Moving on to another possible scenario. When there is a GCF to factor out first. So the first thing that you always want to do before factoring anything is look for your greatest common factor. The previous examples in this video didn't have a GCF, so we can go ahead and factor it. These, we have to factor out a GCF before we use any other method of factoring. So let's look. 2x squared minus 16x plus 14. The GCF that they all have in common is 2. Right, because each term is divisible by 2. Let's go ahead and divide 2 out of each term. We're left with x squared minus 8x plus 7. But we're not done, because now we notice that this inside can be factored more. So we're going to factor that more using the same methods as we previously did. We need two numbers to multiply to 7, but then add up to negative 8. Right? Guess and test, use your number sense. Negative 7 times negative 1 is 7. Negative 7 minus 1 is negative 8. So those are our two numbers. So we're going to write this as x minus 7 times x minus 1. But since we had a GCF at the beginning, that needs to also be brought down. Right? Because if we multiplied all of this together, it would bring us back to our polynomial form. So this is our factored form. Okay, let's try another one. 15x squared plus 33x plus 18. If you notice, our GCF that we need to always factor out first is a 3. So when you factor 3 out of each term, you're left with 5x squared plus 11x plus 6. Okay? Now we notice that this inside is a trinomial that we can factor more. So using the methods that we did, organize our work and go for it. Now this one, we have the coefficient in front. We have a leading coefficient. So we can't write 6 up here. We have to multiply 5 times 6 and write 30. When we combine our like terms, it needs to add up to 11. 5 times 6 is 30. 5 plus 6 is 11. So we go ahead and write it out. 5x squared. We're splitting this 11x, so plus 5x plus 6x plus 6. We're just rewriting this and splitting the 11x into 5x plus 6x. Now we group it. 5x squared plus 5x. The GCF here is 5x. Factor that out of these two terms, we're left with x plus 1. Grouping the last two terms, our GCF is 6. And when we factor that out of the last two terms, we're left with x plus 1. Looking at these, we're going to pull out the x plus 1, and we're left with 5x plus 6. But we cannot, again, forget to bring down our GCF. So this is our final factored form. If we were to multiply all of these out, it would bring us right back to our original polynomial, and that's how we could check our work. All right, so go ahead and try numbers 5 and 6 on your own. Make sure to check your work for these problems, and definitely reach out if you have any questions. Great job. Have a great day. Bye-bye.